Assalamualaikum and good day to everyone. In this video, we are going to discuss on cache memory, which is for our chapter 10. Now, this is the outline of this chapter. So, we're going to start with the memory system characteristic. So, these are the key characteristics that often used to classify the memory system in a computer. The first characteristic is location. So normally when we use this type of characteristic, we are referring to where the memory is located in a computer. So it's either internal or external. Now when we mention internal memory, normally we are referring to the main memory. So another form of internal memory is the cache memory, and the processor also has its own local memory, which is in the form of register. So any memory that is outside a motherboard, or basically need to be connected to the processor via input output controller, is considered as external memory. So external memory is a peripheral storage devices that are accessible to the processor via IO controller. So if you remember back from the video for assembling a computer, okay, we can see that the hard disk of a computer is connected to the motherboard using an input output controller, which is the wire. So hard disk is considered as a storage that is often referred to as external memory. uh, okay, another characteristic for a memory system is the capacity. Okay, so the memory is often expressed in terms of bytes, okay, which is 1 byte equal to 8 bit, or words. So if you remember, the unit word is often equal to the size of 32 bits. Okay, the external memory capacity, or the size, but we often use the term capacity, is normally expressed in terms of byte. Okay, the next characteristic is the unit of transfer. So the unit of transfer for internal memory is equal to the number of electrical lines into and out of the memory module. So it might be equal to the word length, or sometimes larger, such as 64, 128, or 256 bit. Okay, another characteristic for memory system is the access method. So there are 4 access method, which is sequential, direct, random, and associative. Associative method normally is referring to the access method for cache memory. For sequential, direct, and random access method, okay, please refer to an additional video that I provided for you to have more understanding of this access method. Next characteristic is the performance. So there are 3 main metric, okay, for performance of memory system, which is the access time, okay, memory cycle time, and transfer rate. But for this particular chapter, we are going to focus on access time. So the access time, okay, it's either, for random access memory, it's either the time it takes to perform a read or write operation. And for non-random access memory, the access time is the time to take to position the read and write mechanism at the desired location. So we're going to look at this access time in a later chapter. So these are the physical type for the common memory system. Okay, it's either semiconductor, which is this one. So this, I'm sure you have seen or familiar this type of form. Okay, so this type of memory often referred to as the RAM. Okay, and then we have the magnetic surface memory. So this is referring to the hard disk of, and then we have optical form. So this is for our CD-ROM, and finally the magneto-optical. So this is we refer to as a floppy disk, okay, which are not being used anymore in our current computer configuration. Okay, another characteristic is the physical characteristic. So the memory system, we can have either volatile, non-volatile, okay, and then we have a magnetic surface memory, semiconductor, and non-erasable memory. So volatile memory means that the information is lost when the electrical power is switched off. Okay, so RAM is normally referred to as a volatile memory. For example, when we uh, use applications such as Word, Microsoft Word, okay, normally when we want to open Microsoft Word, we have to use RAM, okay, to open any types of application in computer, for example Word. So when we type in something, okay, it's still, we still use the volatile memory, which is RAM. So if suddenly our computer is being shut down, okay, either because of the power is out, or the computer system crash, then the information is lost. So that's why when your computer crash or shut down unexpectedly when you are using an application, when you start back the computer, it does not show the words or the application that you use before that, before the computer being shut down, because of the volatile memory, which is the RAM, that is currently being used to open the application. Now, uh, in any case, when you use a word processor, okay, when you type in your, let's say, assignment, okay, after you have saved at the hard disk, so if your computer suddenly or unexpectedly shut down, okay, your assignment is still there in your hard disk, because the hard disk is non-volatile memory. So non-volatile memory, once recorded, information remain without deterioration until deliberately changed. Okay, so the magnetic surface memory is considered as non-volatile memory. Semiconductor can either be volatile or non-volatile. For non-erasable memory, okay, normally this is referred to as read-only memory or ROM. So in a computer system, the BIOS is often being saved into a semiconductor memory of ROM. Okay. So, and finally, the final characteristic is the organization. So the organization just refer to the physical arrangement of bits to form the words. After we have looked into the characteristic of a memory, the next thing that we want to look at is the concept of memory hierarchy. Now, when we uh, design a computer memory, okay, or when we discuss about the memory system, normally the system, okay, can be summed up by 3 questions, which is how much, how fast, and how expensive. So these 3 questions came up with 3 main uh, characteristic, which is capacity, access time, and cost. So the trade-off between these three characteristics can be shown in a memory hierarchy. So the most highest part in the hierarchy is the register. So the register has the lowest access time, okay, but also it has the lowest capacity, and it has the highest cost per bit. So as the hierarchy move down, okay, the cost will be decreased, the cost per bit will be decreased, okay, the capacity will be increased, and then the access time also increase, and the frequency of access, okay, by the processor will also decrease. So here at this part we have the inboard memory, or we refer to as the internal memory. So in the internal memory we have register, which is the local memory for processor. Then we have the cache memory, and finally we have main memory. Okay, going down of the hierarchy we have the outboard storage. Okay, in the outboard storage we have the magnetic disk. So the outboard storage can also be referred to as the external memory. So the magnetic disk basically is our hard disk. Okay, then we have the CD-ROM and all the related optical type of storage. And finally we have the offline storage, which is magnetic tape. So the magnetic tape is often used in a mainframe. In our current technology, we also have something. Let me okay, we also have something that we refer to as SSD. So I'm sure you all know that this is called solid state drive. Okay, so the question is, where is the SSD located in our memory hierarchy? So SSD, okay, SSD, if we want to use SSD, we still have to connect the SSD using a wire. Okay, sorry, or I/O controller. Okay, so we are talking about a PC system, not a laptop. Okay, so in a PC or a computer system, SSD, if we want to use SSD, we have to connect to the motherboard using an I/O controller. Okay, but of course we know that this has a faster, okay, access time compared to magnetic disk or hard disk. Okay, compared to hard disk. So the basically SSD is located here. Okay, it's above the hard disk because it is faster. It has faster access time compared to hard disk, and it is in terms of cost, it is quite expensive compared to hard disk, but it's not as expensive as main memory. Okay, and but it still has higher capacity than the main memory compared to it has a higher capacity compared to main memory. Okay, but considering that it is faster than hard disk, and it is expensive than hard disk, but it has to be connected to the motherboard using I/O controller, then it's still located at the outbound storage of the hierarchy, but above the magnetic disk. Okay, next we're going to look at the cache memory principle. Before we continue, I would like for you to access another video that will introduce you to the cache memory principle. After that, we can continue with our video for the mapping technique.